I'm Luke.
I'm Everett.
I'm Jackson.
And I'm Kane. We're here to talk about Newton's first law.
The man you see, his name is Isaac Newton. He was born in 1642 and died in 1727. Some say he was the greatest scientist that ever lived. More than any other person, Newton was single-handedly responsible for laying the groundwork in classical mechanics, optics, and even mathematics. Landing man on the moon? Don't look at Einstein. It was all done with Newtonian physics. He wasn't even expected to live. In 1642, the year that Galileo Galilei died, Isaac Newton was born prematurely on Christmas Day. Named after his father, who died 3 months before he was born, Isaac was a very small baby, not expected to survive. Newton's first law states that an object in motion stays in motion
Until an outside force acts upon it.
Luke was the outside force acting on the ball.
The forces between mine and Luke's hands are equal, but when Luke starts pushing harder, the force is greater in his point, and then when I push harder, the force is greater in my point. And then they come back to normal when the forces are equal, and then the same again, the second time.
An object at rest stays at rest until an outside force acts upon it.
My arm was the force acting on the ball, which was at rest.
The ball will keep rolling until a force acts on it. Luke is the force acting on the ball.
The ball will keep moving until an equal or greater force acts on it. The ground is the equal or greater force.
The grip on this ball helps me be able to palm it. Palming the ball would not be possible without friction in the grip on the ball in between my hands.
Fluid friction is acting on the ball in the air until a greater force, the backboard, acts on it.
Dry friction resists relative lateral motion of two solid surfaces in contact. Dry friction is subdivided into static friction between non-moving surfaces. The friction between the car and the top of the loggers is less than it would be on another rougher surface, such as the sandpaper that you will see in a second. That's why the car will slide further. As I slide the car across the sandpaper, there is more friction between the sandpaper and the car than there is against the car in just a normal table. The car goes fluently across the table, but slowly across the sandpaper. When you push it sideways, it flips over. When you push it sideways, it slides fluently across the table.
Jackson is in motion. He will continue to move in motion until the greater or equal force acts on him. The wall is the greater or equal force that stops Jackson from being in motion.
Luke's legs are putting him in motion, and gravity is pulling him back down to the earth.
Gravity was the same force that acted on a lot of our tests. Gravity attracts all objects toward Earth. Gravity's been around since the very beginning of the universe, and it works the same way everywhere in the universe, on all kinds of different objects, on all different sizes. This is definitely a force that has to do with Newton's first law. The basketball shots, the Luke's jumps, and even us just walking around because gravity is holding us to the ground. The bigger an object is, and the closer you are to it, the stronger its gravitational pull is.